Hello everyone. Today I would like to discuss about data types in C. In fact, in the earlier session, we were talking about keywords, variables, and constants in C. And now I hope everybody is okay with defining their own variables and constants. And you might aware that the keywords there are 32 keywords in C language. These keywords should not be used as variable names. And with that, let us proceed further and try to explore the data types in C language. So in this session, my objective is to teach you what exactly mean by the data type and what are the different data types available in C and how much memory gets allocated the moment when you declare a variable with data type and the maximum permittable values that can be assigned to the variables which are declared with a specific data type. So these are the essential elements someone has to know about the um, about when you talk about the data types. Okay, so let us see. So let us look at these available data types in C language. So in fact, the chart given here lists out all the data types supported. So in fact, so initially we will be focusing on primary data types, or we say uh, built-in, or um, these are also called as predefined data types in C. In fact, the most important data types that we initially start using, one is character, int, float, divide. So we call them as predefined built-in or primary data types. So these data types are supported by the C compilers. You can see different flavors of these data types. So again, we have user-defined data types. In fact, the user has the privilege to define his own data types. In the sense, he can customize if you want to define his own data type. A user has given opportunity to do that with the help of the keywords. In fact, all these data types are lowercase letters. So this E is in fact it is small e. Enum is one keyword can be used to define user-defined data type. So normally this is used to define or assign values to the names or numbers to the names. We will talk about this later on. Type def is also used. In fact, this is not capital. So all these are keywords. Type def can be used to define user his own data type, or we can say that to give alias names to the existing data types. This type def can be used. Now, of course, in the later on sessions, we are going to define pointers, arrays, structures, and unions. Of course, these are derived data types. So these can be defined with the help of the existing data types. Say structures can you can define using the keyword say struct, and union you can define using the keyword union. So no, the point is, of course, knowing about the data types, that's all fine. But how do you define data type? For example, if somebody says variable as say int x, so in the interviews, the preliminary question will be asked is what is data type? How do you define data type? So from this declaration, I would like to derive the definition because student often struggles a lot to remember this definition. So x is a variable of type integer. So if you say int is the keyword, what does it mean? The compiler knows that x is an integer variable. Means so by writing this int keyword in front of this x, that qualifies the x as integer variable. So what does it mean? The implication is that so the data type is telling the type of of data variable can hold can hold during the execution of the program. So you can note it, execution of the program. So because the data type pre-qualifies the variable that can have values during the execution of the program. So because here x is declared as integer, so x can be assigned only with integers. X could be given as 3 or x could be given as 10. This is okay. But for x, if you give say 10.3, it is not okay because the data type of x is int. So int specifies that x can have only integer values during its execution. So that's what data type is actually qualifies when you write it in front of the variable. So data types are basically these built-in or predefined data types are basically used to declare the variables. Now, if you look at this, yeah, if you look at this, we have basic primitive data types, four types: char, float, int, and wide. So again, when I say if you take any data type, there are different flavors. Say int is taken. So if I say int x, okay. Now here x can be given positive value and x can be also given negative values. So that's what, in fact, this can be considered as it is a signed system. We use the keyword signed. This is actually signed int x. What does it mean? Means x can take either positive, either negative. Both are okay. So signed is a keyword that is used along with the basic data type to represent that both the positive and negative values can be assigned to a variable. In fact, when we write the program, so we don't write the signed keyword. So default when you say int means it is signed, means that can be taken, that can be assigned either positive or negative values. But you can see if you want to restrict the domain of the variable only to positive values, then you can apply one more keyword called it as unsigned. Unsigned say int x. Now x can be given only positive values. 3 is okay. But if I assign x is equal to minus 3, it is not okay. So you can see the signed and unsigned before the data types, before the data types on screen. Just signed and unsigned, these keywords are used to represent whether the variable can take positive values or negative values. So apart from that, we will discuss one after another the rest of the data types. Let us see the basic data type. When students start learning C program, we say it is int. In fact, int has different flavors. Like in int, you have short int, long int, and in fact int. So this by applying the keyword short and long, so that simply used to allocate the memory for the variables. You can define some variable as short int x or long int x, or you can say int x. Okay, and this you can apply signed keyword. Okay, that represents the positive and negative. Even if you don't apply, default sign is applicable. But if you want to assign only positive values for this x, that should be unsigned, must be applied before the uh, declaration of the variable. Okay, it could be unsigned short int, unsigned long int, and int. So, however, see how much memory will be allocated. We will see. We will see now. Prior to that, say if you want to print the values of these variables, for int we use percentile d, and for long int we use percentile ld, and even for the short int you can use percentile d. In the similar way, in char we have only signed char char x, unsigned char. What does it means? So you can use percentile C to print or scan the value of the character format specifier used, whether it is signed or unsigned. So percentile C. In fact, what is the point of writing signed and unsigned before the char? So because the characters normally represents a one is a character, A is a character, any special symbol is taken as a character. So the point is, so for characters, to represent the memory of a character, so you need to learn about the ASCII equivalent values of the characters. So in fact, the characters are stored in the computer memory with their ASCII equivalent values. So we will do one session on ASCII, how to know the ASCII values of the character right now. So for signed percentile C. In the float, we have again variations. It could be, see, a float can be normal float, it could be float x, or it could be double x, or it could be long double x. So I talk about the sizes, memory sizes and maximum and minimum values that can be used. Prior to that, there are three variants that in which you can declare a variable as a real variable. So fine. So again, for this we won't apply the keyword signed and unsigned because their representation is different in the computer memory comparatively with the integers. Fine. So we use percentile f to either scan the value or print the value. You can use percentile uh, LF, and for long double you can use percentile capital F, capital L and F. Of course you can manage it, this double also with percentile F. The difference is with the precision. So we have 6-digit precision here. Means what does it mean? After the decimal, after the point, you can print the 6 decimal values. Here we have 12-digit digit precision, and for the long double, of course, memory is more. You can have 12-digit or 12-digit precision. So the values of the variables will be printed after the decimal point. You can have 6 digits for float and 12 digits for double. So apart from that, we have one more data type. In fact, void. Void means nothing. So this could be also used as a generic pointer. I talk about this void and then in the later classes. Means when the function is returning nothing, or if you want to deal with a pointer that can able to hold the address of any variable, we define it as a generic pointer. So that we will discuss in the later courses. So these are the preliminary issues. So, what are the different flavors of these data types and what kind of percentile the format specifiers are used to with these data types. Now let us see the size of the data types. So I would like to talk about the sizes of data types. So in fact, this one has to know the size of a data type is system architecture dependent. System architecture dependent. What does it mean? System architecture means we have operating system and we have processor. So when we write the C programs, we have compiler. Fine. So the compiler will be talking to operating system and operating system will be talking to the processor. The communication happens between these three and our C program gets executed. So when this happens, in fact, so how much data at a time compiler can submit to the OS and how much data OS can at a time submit to the processor. Or other way, you can also understand like this: how much data processor can process in the memory at a time. and how much data operating system can read at a time from the memory, or how much data can be processed by the compiler. So each one has their own capability. So based on that, so the data type, this memory for the data types will be allocated. In fact, so now see, the compiler is a say 64-bit compiler, means the compiler can able to handle 64 bits of data at a time. And we expect the because the compiler will submit 64 bits data at a time, OS also could able to process 64 bits at a time, and the processor also could able to process the 64 bits at a time. So then everything is fine. But if compiler works on 64-bit, operating system is 32-bit, compiler supplies 64-bit to process that, operating system has to read twice the data because the operating system is 32-bit compiler. So that is the reason why the data type memory allocation depends upon the, mostly we say it depends upon the compiler. So I can say that data type uh, size of the I say size of the data type, it depends on, let it be right now, depends on compiler. Okay, so I can say what type of compiler you are using, that is most important to allocate the memory for the data type. In fact, whenever you are writing a C program, there is a way to know how much memory is being allocated for the data type, because it is mission dependent. Now you try to understand, it is a mission dependent purely, because you know what on what operating system you are running the program, on what processor you are running the program. If you know the operating system and the processor, that's fine, but sometimes we run the program in a network. Okay, so as a client you will write a program and this is a network. Okay, you access the online compiler from the network. You don't know the service provider is using what architecture, what system architecture is using, what compiler is actually using. So you don't know. Because of that reason, you could not able to predict the size of the data type in advance. To know the size of a data type or the memory allocated for the data type on a particular mission, we have the operator called as size of operator, size of say int. So it will give you the size of the integer on that particular mission. So how much memory is being allocated on a particular mission will be given. So now try to understand. So imagine that I am running a 64-bit compiler. Compiler. Mostly we this happens in the Linux environment. Okay, in the Linux environment, the data type sizes I would like to write. For say we have short int is 2 bytes. We have int is 4 bytes, and we have a long int, it is 8 bytes, and we have float, it is 4 bytes. We have double, it is 8 bytes. We have long double, 10 bytes. In fact, there is a variant called as long int. In the int, still even this for this also we allocate the 8 bytes. Fine. And of course for the char, on any mission, on any compiler, you can standardize this. 1 byte of memory is allocated. 1 byte. Fine. And of course, when I am talking about this memory, size of the memory, this memory for signed and for even unsigned, memory is same. Remember, memory size. Memory size is same. Only thing is that so for positive numbers, when we use 1 bit of memory to reserve the sign, and for unsigned numbers, so, signed numbers are represented using bit 1. One of the most significant bit of the memory representation is used to represent that number is positive. Sorry, 0 is I think for the positive and 1 is for the negative. That we will see. So I will talk about that, how much maximum and minimum values that can be placed to a variable is declared as a integer. Fine, that's what. So we will, in fact, we will do a live session on this to know. We will write a program, C program, on online GDP, where we can come to know the sizes of the data types. Now I would like to discuss the maximum and minimum values. So prior to this, I want to know, I expect the students, they know the computer understands binary number, So I expect that they know binary system and decimal number system. For example, if I have say two binary numbers, two binary bits, if I have two binary bits, so what are the possible combinations of two binary bits? It could be 0 0, 0 1, 1 0, 1 1. So decimal equivalent of these, I expect the students to know how to convert this binary number into decimal number. Please, the decimal equivalent of this one is 0 1. Sorry, this one is 0, and this is 0 1, and this is 0 2, and this is 0 3. Means it is 0, it is 1, and it is 2, and it is 3. Fine. If I have three binary bits, try to understand. If I have three binary bits, so what are the combinations of three binary bits? 0 0, 0 0 1, 0 1 0, 0 1 1. Let it be say 1 0 0, 1 0 1, 1 1 0, and 1. What is the other? So it is 0 1, decimal equivalent 2 3 4 5. This is 6. Last one is 7. So from this I want the students to understand. So if I have two binary bits, the minimum decimal value I can represent is 0, and the maximum decimal value I can represent is 3 for 2 bits. Here with 3 bits, the minimum decimal value that I can represent is 0, and the maximum decimal value that I can represent, sorry, this is all triple ones, 1 1 1, triple 1. So it is 7. So it is 7. So means if I have, if I can come to know, if I have n binary bits, if I have n binary bits, so what would be the maximum decimal value that I can represent? So here in this case, n is equal to 2, and here in this case, n is equal to 3. So I can see the minimum value is in both the cases it is 0, and the maximum value I can frame like this, 2 power n minus 1. What does it mean? So n is 2 because number of bits, n stands for number of bits. So 2 square minus 1, this is 3. And here the minimum value is say 0, and the maximum is 2 power n minus 1. So let it be n is equal to 3, 2 cube minus 1. Now it is 8. Fine. If I have n binary bits, the minimum value is, now I can come to write decimal value that can be represented is 0, and the maximum decimal value is that can be represented is simply that is 2 power n minus 1. Fine. So from this we will try to let it be, let me remove. Let us know the sizes of the integers and also characters. So if I say I declare one variable as x, right? So I said what is the memory allocated for this variable? Imagine that on 64-bit compiler, let it be 4 bytes. 4 bytes means how many bits? 4 into 8 bits. What is that? it is 64 bits. Sorry, 4 into 8, it is say 32 bits. 32 bits of memory is being allocated. So let me write this number of bits here. So imagine that. So these are 32 bits. I said because what is this now? X is a positive integer by default, positive and negative by default sign will be there. So one bit is reserved exclusively to represent the sign of the number. This is to represent the sign of the number. And how many bits are remaining? So the our remaining bits will be 31, right? So on. Wait for a while. Yeah. So on. Right. So remaining 31 bits will be there. Fine. If x is equal to say, if I give x is equal to say 4, the binary equivalent of the 4 is 100. So I can write 100. Right, 100 is 4 and the remaining all will be in fact zeros. So by adding zeros towards the left does not increase the magnitude of the number. So this bit, because now x is given positive and this will be 0 because positive. If it is negative, this will be taken as 1 for negative. So one bit is used for representing the sign of the number. So remaining 31 bits are there. So how many bits are there? Remaining all these are 31 bits. Means this time n is equal to 31. So what is that maximum value that we can represent with the 31 bits? That if you can able to know, that is fine. So how do you know? So we have the formula now. The minimum value that I can represent is all zeros. 31 could be zeros. And the maximum value is in fact, so that is 2 power n minus 1. That implies that is 2 power 31 minus 1. So this is the maximum positive value. Maximum positive value that I can represent, decimal value that I can represent to the x. For example, if it is character, we would have, yes, let it be character. If I say char x, okay, how much memory? Say 1 byte means 8 bits, we can write it. 1, 2, 3, 4, 5, 6, 7, 8. And char means by default it is signed, it is positive, so the most significant bit is given as 0. So how do you convert this x into binary value? I said if you give for x any character, say, and the ASCII value of this character will be considered, in fact. So the 7 bits are used to represent the magnitude. So how many bits are there? 7 bits are there. So the minimum value would be 0. What is the maximum value for this? 2 power 7 minus 1. That is 128 minus 1. It is 127. So the minimum value, minimum positive value is 0 and maximum positive value is 127. If somebody assigns the value more than 127, then it will be an error because the value given to the variable could not be fit into the actual memory allocated for the variable. In that way, you could able to calculate the sizes of the variables. And one more point I would like to tell you at this here is, see, uh, so let me erase this. Wait. Yeah. So one more point is what a character, for example, if I say char x, so in textbooks you will find minimum value is minus 128 to maximum value is 127. So if you look at the minimum range is always one higher than the positive. Negative range, negative is always one higher than the positive. Means this will be negative can be written as the maximum positive plus 1, in front we have negative sign. That will be the ranges if you see in the textbooks. So what about this negative value is one is more than that. In fact, if I declare, let us try to understand this in the way. So int x is equal to 0. Fine. So if x is equal to 0, how do I represent in the memory? So x is a positive 0 or negative 0. For x we can, for 0 there is no sign. So normally by default it is taken represented as positive. Remaining all will be zeros. Remaining all will be zeros. Fine, so on. 31 bits. And if somebody try to assign a negative 0, is it possible? It is not possible, but what you need to do, let me erase it. How do you give the see negative values? So in fact this is practically not possible, but what I can do is, let me write. So you have to write, because it is negative, the sign bit should be 1 and remaining all will be zeros. This is a special case. This is the special case. For example, let it be, so I will shortcut these zeros, sorry. Um, uh, so this is a special case. In fact, as negative 0 is not there, and we won't write negative 0 in mathematics. So this can be understood as when reminding all the zeros, all the bits are zeros except this most significant bit of the memory representation. In fact, the compiler has to treat this as a negative 0, but negative 0 is not there in the mathematics. So what compiler will be doing is, when remaining all are zeros, only most significant bit is 1, the data is taken as the magnitude. This entire data is taken as the magnitude. Means the binary value is this one now. 1, 2, 3, 4, 5, 6, 7. So this could be 2 power. What is the value? This one. How many bits are there? 1, 2, 3, 4, 5, 6, 7. Means 2 power 6 minus 1 is the 2 power 6 in fact, right? This is 2 power 6. What is that 2 power 6 value? If I add one more 0, so 2 power 7 means this is 128. So this 128 is calculated, and because all are zeros, the only one is there. The complete number is taken. Number of bits are taken as magnitude, and in fact it will add the negative sign prior to the number. So that will be the that is the reason why for the last digit in the minimum range can have one value more than the positive range. Got my? I wish you got my point. So for negative numbers, so all the bits are zeros, and all the bits are zeros, all the bits are zeros, and the most significant bit is only one. In such case only this is taken as a special case. This is taken as a special case, and the complete number of bits are taken as magnitude of the number, and number is calculated because one is there, then it will add negative sign to that. That's why even on 60-bit compiler, if you see in the textbooks for int x, if it is on 16-bit compiler, the positive is the range is minus 32,768 to they write it as 32,767. This happens even with the integers on 16-bit compiler if the for x 2 bytes memory is allocated. And in fact, so that way negative range will be one more than the positive range. Fine. So what else left over is, I think we have two more data types to discuss. That is, one is enum and other one is type. So we will write programs on this enum and type as and when they comes into the picture. Prior to that, let me introduce. Enum is a data type which is used to assign names to numbers. Assign names to numbers. Names to numbers. And type is used to define. Is used to define. It is used to define user defined data types. User defined data types. What is? Let us see one after another. So if you want to assign names to the numbers, you can use the keyword enum. For example, enum week, you can define the list of variables in the week. Let it be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Fine, right? So what happens is when you declare the variable as a enum, so enum variables they can take the set of values. So this set of the list of values that are taken by the variables has to be placed in the open curly brace and closed curly brace. You can see. So what happens is by default the compiler assigns values for them 0, 1, 2, 3, 4, 5, 6. So initialization starts from 0. Okay, if you print any this variable, say if I say printf percentile d, say, t, what would be the value? The value of this would be 2. In interviews, people will ask you like this. Sometimes this could be given as enum week, say Sunday, s is equal to 2, m, comma t, comma w, say 6, comma. So what is the value of this? So whenever if you don't assign the values, by default they start from zeros, but if you externally supply the values for the enum variables, so to get the m value, you will see the previous variable's value. If it is 2, and this will be 3, and this will be 4, and this will be 5, and this is already assigned 6. Now this is assigned 6, so f will be 7, and this will be 8. So that's what the question is. Fine. So apart from that, to type def, you can use type def, for example, to define the new data types. So let me type def, say int as integer. So I would like to rename that built-in data type int as integer. Later on, how you can do this is integer x. So if you want to customize the predefined data types, you can use this type def to give the alias names to the existing data types. In fact, this type def is mostly used with the structures. For example, if I define struct, say struct link list, so link fine, you do something. So later on you want to assign new name to this struct link, then you can go with type def struct link, say node. So what happens? This struct link is actually user defined data type is given alias name as node. So later on you can use node star add. This will be the pointer to the linked list. So this concept we will explore when I talk about these structures. Okay, guys, that's it from my side. So apart from that, the rest of the data types, that is the derived data types, so we will discuss as and when they comes. Okay, that's it from my side. Thank you.